Hi class, this is Dr. Karsten, and today we are doing lesson 11. This is grade 4, module 5 of EngageNY Math. And for this lesson, we are going to continue working with fractions, and we're going to continue decomposing and composing those fractions using multiplication and division. What is going to change today a little bit is that we are not going to limit ourselves to tape diagrams and area models, but instead we are going to now add number lines into the mix. So let's go ahead and get started. I have a few examples that we're going to work with first before we get into the problem set. And the first example, what I'd like to do is let's draw a tape diagram. So I'm going to go ahead and do that. And then the next thing that I want to do with this, I want to show first that this is going to represent one whole. And I do that by bracketing it off. And then the first thing that I want us to do is I want to partition this or break it apart or into two pieces. So I'm going to decompose it into halves. So let's go ahead and do that. I'm going to put a line right around the middle. And then to show that I'm interested in one half of this, I'm going to go ahead and shade one side. Alright, so I have now represented one half, and I'm going to go ahead and write that right here, that this represents one half. Now, let's say that I wanted to decompose those halves, so I really have a half here and a half here. I want to decompose this entire tape diagram into fourths. So before, when we did halves, we had two pieces. The total number of units was 1, 2, and the number that's shaded is 1. Now I'm going to want to make that a total of 4 units. So let's see what happens when I do that. So to do that, I'm going to go ahead and decompose each of those halves. So now we have 1, 2, 3, 4 pieces, so we have fourths, and 2 of them are shaded. So I'm going to go ahead and represent that. Now, I can show that using a number sentence and multiplication. And this is from a couple lessons ago. Let's go ahead and just really quickly write that number sentence as a review. So what I could have done is said that I have 1/2, and I want to turn that into 2/4. And the way that I did that was by taking each half and decomposing it into 2 more pieces. So you could also say that this entire side has 2 pieces. When we're doing that, we're taking 1/2 and we're multiplying by 2. And remember, whatever I do in the numerator, I have to do in the denominator, because 2 over 2 is equal to 1. That's something that we've been working on. So the other thing that, remember, we've also said is that I could kind of say, oh, well, how do I turn 1 into 2? I multiply by 2. Or how do I turn 2 into 4? I multiply by 2. That was the other way that we've been looking at these. So this would be our number sentence using multiplication to show this. So the next thing that I want to do, we started with a half, we turned it into fourths. Now what I'd like to do is I would like to turn those fourths, or decompose those fourths, pull them apart, into eighths. So I'm going to go ahead and just write an 8 down here. And to do that, I'm going to go ahead and just split these, or partition them, each in half again. So I'm cutting them all into 2 pieces, each of them. So now let's see how many are shaded. 1, 2, 3, 4. So I have a total of 8. 1, 2, 3, 4, 5, 6, 7, 8. That's my denominator. And that's the total number of units. And then I have 4 that are shaded. Now, I don't know if you also noticed that as our denominator increased in size, the number of pieces increased, but the size of the pieces got smaller. That's something important for us to remember while we're doing these. So now let's show with a number sentence how we turned 2/4 into 4/8. So again, I'm going to write my 2 over 4, and I'm going to set it all up. Remember that we always rewrite this fraction to show what we're doing with it. I want to use multiplication again. When I'm decomposing, I use multiplication. And so now let's go ahead and look. And I could either take a look and see what did I do with each one of these quarters. I split it into two pieces or partitioned it into two pieces. So I'd know that I put 2 over 2. Or the other option is to say, how does 4 become 8? Or 8 divided by 4 gives me what? And that would be 2. So I'm going to put 2 over 2 because we did the same thing, and I can check this. 2 times 2 is 4. 4 times 2 is 8. So it worked. So now what we want to do is we want to start working with a number line. Now, to kind of make it a little easier, I'm going to go ahead and redraw our tape diagram. And I don't think that you need to watch me do that, so I'm going to slide this up and just pause this for a second so that we have it. Okay, so here we go. I have this drawn for us, our new one. So now remember, we know that where this is, that this was half of it. Let's go ahead and draw a number line underneath our tape diagram. Make it slightly larger than the tape diagram. Now, if you have a ruler and you want to make it look really nice, go for it. Otherwise, do your best to draw a nice straight line. I'm going to go ahead and put my arrows on the end. And then the other thing that I want you to do is I want you to, at the points where it aligns itself or lines up with the ends of your tape diagram, you're going to put marks, and you're going to put a 0 at one end, and you're going to put a 1 at the other end. Now, just like we did with the tape diagram, let's go ahead and let's make a mark and label 1/2 on our tape diagram. So 1/2 is going to be half of the distance between 0 and 1. So I'm going to go ahead and put a mark here, and I'm going to label it 1/2. Now, just like we did earlier with our tape diagram, let's go ahead and decompose this into fourths. So I'm going to go ahead and put 1 mark here, 1 mark here. So now I have partitioned or split or cut this up into 1, 2, 3, 4 pieces, and those are each going to be a fourth. So let me go ahead and label them. So this is 1/4, this is 2/4, this is 3/4. So as you can see, I went ahead and I labeled these, and now you can see that 1/2 and 2/4 are equal to each other. They're equivalent. Those have equivalence. And again, just like we did before, we could have done a multiplication sentence or a number sentence using multiplication. But before we do any of that, let's go ahead and let's now decompose all these fourths into eighths, just like we did before. So now I need to make 8 equal pieces instead of the 4. So I'm going to go ahead and add in little marks in between each of these. And now I can go ahead and label these. That this is 1/8. So I have gone 1/8 of the distance from 0 to 1. Then if I go another, and I like to call them hops, so it's like hop, hop. Then I will have gone 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then I could actually put 8/8 over here. I could have put 4/4 and 2/2, which would just show us that 1 is actually equivalent to 2/2 or 4/4 or 8/8. So, you know, I kind of would like to add those in for you, just so you know that they're all over here. So we have 2/2, 4/4, and 8/8, just to show that they do line themselves up. Oh, you can't see it, sorry, with 1. Okay, so there we go. So, so now what we could do is, since we can see that these all line up together, we can clearly see that they're all the same value on our number line. We can actually go ahead and write that down like this. We can say that 1/2, let me move this up, that 1/2 is the same as 2/4, and I can also say then that 2/4 is equal to 4/8. They're all equivalent. So by this, I can say that 1/2 is equivalent to 4/8 also. Okay, So now we are going to do another example where we are going to use another number line, and again we're going to use multiplication and division to decompose and compose fractions. So let me get us set up with a fresh piece of paper. Trying to slide it down so I can use the whole thing. All right, I think we're ready. So for this example, I am going to start again with a number line. I just want to shift this around one more time. Okay, so I'm again going to start with a number line. Or actually, I guess last time we started with a tape diagram. This time we're starting with a number line. And I do want to start by making a mark here, and that's going to be equivalent to 0, but I'm not writing that in yet because I want to write it a little differently this time. And what I want us to do is I want us to turn this number line. I want us to decompose it into thirds. So again, thirds means that there are going to be 3 equal pieces between what I know is 0 and 1 because I've told you that. So let's go ahead and do that. And I'm going to go about here and about here. It's good enough. Looks pretty equal to me. Now, since I'm decomposing this into thirds, instead of writing just plain old 0 here, what I want us to do is write it as 0 thirds. And then once I've gone from here to here, I've traveled 1/3 of the distance, or I have a third. When I get to here, I've gone 1/3, 2/3. And then when I go from here to the end, which I know is equivalent to 1, what I'm actually going to write is 3/3 for our purposes. Now again, I could have put a 1 right here. That would be fine. But just right now, since I'm talking about thirds, I want to stick with that. Now, what I'd like us to do is I would like us to take the third, this first third, and let's decompose it into 4 equal parts. So I'm going to go ahead and show that I'm going to do that. I'm going to write 4 equal parts above here to show what I want to do. And let's then go ahead and do that. Remember, when you're dividing into 4 equal parts or splitting to 4, you're going to make 3 marks in between. So now the question is, what do each of these represent? What do we have happening here? Well, if each of these is 4 equal parts, I could just count by 4s, and I could say I have 4, 8, 12. So my new denominator is going to be 12. Now, I don't really want to draw them in, so I'm just going to do it really lightly, just for those of you who are having a little trouble following this. I'm going to very lightly in pencil put those in, but I want us to try and really use our mental math abilities to do this. So those are lightly in there for those of you who need it. You can now count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But again, if I know that I am decomposing each one of these thirds into 4 parts, I can just count by 4. 4, 8, 12. So let me write that in now that I know that I have 12ths. So I'm going to start with 0 12ths. Then I'm going to have 4 12ths. Then I'm going to have 8 12ths. And then I'm going to have 12 12ths. And again, numerator and denominator match. That means that I have cut it or split it or decomposed it or partitioned it into 12 equal pieces, and I have all 12 of them. So I can kind of put all those pieces back together to make one whole, which is why I have that 1 up there for us. So now let's show what we did using a number sentence. So if I wanted to show that we took this third and then we decomposed it into 4 12ths, let's go ahead and show that number sentence. And again, when we're decomposing, when we're making more pieces, we're going to multiply because we're making more pieces. The pieces are smaller, but we're making more of them. So let's go ahead and show that. So I would start with what I'm starting with, my original fraction, which was 1/3. And then I'm going to show what I'm doing with it, and we already said we're multiplying. And then I'm going to set that equal to 4 12ths, because that's what I wanted to end up with. So the way that we turned that 1 into a 4 was we multiplied by 4. We cut it up into 4 equal parts. And we did the same thing with the entire thing. So these 1, 2, 3/3, we also multiplied them by 4. Whatever we do in the numerator, we do in the denominator, and vice versa. Whatever we do with the denominator, we have to do with the numerator, because 4 over 4 is 1, and multiplying by 1 doesn't really change things. We're just cutting up the whole thing. Okay, so we have now shown this using multiplication. Could we show it the other way? Could we show composing or putting together 4/12 into a third? Could we kind of show gluing all that back together? Well, let's try. Let's start with 4/12. Let's set it up and show that we have 4/12. And now we want to turn those 12ths back into thirds. How did we do that? How could we possibly do that? Well, when we are trying to make all of those pieces, when we're trying to put them back together, when we are composing, we are actually going to do division. And for 12 to become 3, what I would have to divide it by, and if you don't know this, you could always say that 12 divided by 3 is going to give me that answer. Remember that we can flip that. And we know that because 12 can have 3 and some other number over here as its factors. So 3 times what is 12, or 12 divided by 3 will give me that. And I can go either direction, so you should get a 4. And we know that because we did 4 equal parts. So even if you didn't know that right now, you could have just figured it out by looking above. And so now 4 divided by 4 is 1. And look at that, we showed it again. Okay, so that is the main idea for this example. I do have one more example that I wanted to show you. So let me just slide our paper up again. And I think I have enough room. Okay. Okay, so for this example, we are going to be decomposing a non-unit fraction. So remember, unit fractions have a 1 in the numerator. In both other examples, we were decomposing first 1/2, so it had a 1 in the numerator. And in the second example, we were decomposing 1/3. So again, it had a 1 in the numerator. Those were unit fractions. This time, however, we are going to be decomposing a non-unit fraction. So let's go ahead and first draw ourselves a number line. So exactly how we've been starting this. I'm going to draw a nice number line. And then for this one, what I want us to do is to partition it into fifths. So first let me mark off where my 0 is. Let me mark off where my 1 is. So this is again going to be 0/5. And this one is going to be 5/5 because that's just equal to 1. So if I am partitioning this into fifths, that means that I need to draw 4 lines. So that's going to be a little trickier than what we've been doing because I don't have a middle line. So I'm going to do my best to try and make these all equal. That's pretty good. And let me go ahead and label all of my fifths. So when I go from 0 to here, I've gone 1/5 of the way. This is 2/5. This is 3/5. This is 4/5. And we already wrote in our 5/5. So that's a pretty good job. Now, here's the thing. I would like us, let's focus here, let's put a dot at 2/5 because this is what I want to work with. I just want to work with these first 2/5. And what I want to do is I want to partition or decompose, I want to partition this into 6 equal parts. Now, oh wow, my hand looks really big, doesn't it? Into 6 equal parts. So I cannot, and I know a lot of you are just going to be like, oh, well, okay, I'm just going to go and put, 5 lines in here, make this 6 parts, make this 6 parts. Don't do that because you're not paying attention to the fact that we are decomposing 2 sections into 6 equal parts. It's a little different. So we are decomposing 2 units, this unit and this unit, into 6 parts. Now you can probably do the mental math and say, well, that means I'm going to decompose each of them into 3 parts. But if you didn't, remember that we always have our math way of doing this. And I actually am going to show you that way first, because knowing my class, I don't want you to get stuck not realizing how to do this. So we have 6 equal parts that we have to decompose 2/5 into 6 equal parts. So let me start down here, and I'm going to go ahead and start doing the actual number sentence that would accompany this straight away. Or at least, you know what, let's just at least do the shortcut. I'm not even going to do the number sentence yet. So I take that back. I am going to do the number sentence. So if I'm doing 2/5 and I want to decompose these two units, the 2 units I have, into 6 pieces, I can go ahead and write that in my final fraction. So I'm going to decompose 2 and turn it into 6. How do I make 2 into 6? When I'm decomposing, I'm multiplying. What would I have to multiply 2 by to turn it into 6? So 2 times some number is 6, or let's do the inverse. 6 divided by 2 will give me that number. And you could go ahead and now divide 6 by 2 in whatever way you know how, and you're going to get 3. And remember what we said before, we're splitting those into 3 equal parts. Well, now you can see why. And then 5 times 3 is 15. So now let's go ahead and do that on our number line. So again, we already figured out now that from this 3, I have to split or decompose each of these into 3 pieces. So I'm going to put 2 lines in between each. I'm just going to make these a little bit more obvious before I do that. So I'm going to go ahead and turn it into 3 pieces. 1, 2, 3. And here's 3 pieces. And I could continue, or I can just count by 3s. And I would know that this is going to be 3, 6, 9, 12, 15. So I have 15 in total when I go to the end, when I've decomposed this. So that's why my denominator is going to be 15. So here I have 0 out of 15. Here I have 3 out of 15. Here I have 6/15. So now we know that 6/15 is equivalent to 2/5, which we know from here. Then I have 9/15. Then I have 12/15. I'm getting nervous. I want to make sure I do this right. And then I have 15/15. Okay, so we have just shown that 2/5, when it is broken into 6 equal parts across both of those units, we end up with 6/15. And we showed it mathematically down here with our number sentence. I think for a lot of you, if I tell you to partition or to decompose 2/5 into 6 equal parts, I think that doing it here, you might get a little mixed up and make those 6 parts here, 6 parts here, which is why I showed you this. You can go ahead and set up your number sentence right away. And you can say 2/5 is equal to 2/5 times some number, and I know I want to make 6 pieces out of that. I want to turn 2 pieces into 6 pieces. I had 2 pieces, 1, 2, I need to divide it in 6. Why would we need to do this? Let's say that you had a cake and you had divided it. Originally you thought that there were going to be 5 people sharing it. You cut it up into 5 equal pieces, but you ended up eating 3 of the pieces with your friends. No one was really that hungry. The next day, you still have 2 of those 5ths left over, but now you have a bunch of friends coming over and 6 of you want to share those. How are you going to cut it? You could figure it out doing this math. So it is a useful thing to understand. You can use this for recipes. There's lots of reasons you might use this when you're building things. So again, I wanted to change 2/5 into 6 somethings. I don't know what they are yet, but I could have figured it out mathematically, or I could have drawn it here. All right, that's the gist of this. I know this piece is probably a little confusing. Remember our rule. First problem, you're confused. Second problem, you're still a little confused. Third problem, you're getting it. Fourth problem, you can do it on your own. So let's jump into the problem set and let's do some problems together so that you'll be fine on this for our math. All right, so let me switch us out into our problem set. Okay, so here it tells us that it says label each number line with the fractions shown on the tape diagram. Circle the fraction that labels the point on the number line that also names the shaded part of the tape diagram. So we're going to be looking at our tape diagrams to understand what our fractions are, and then we're going to go ahead and label them down here, and we're going to circle the one that corresponds with or that also names the shaded part of the tape diagram. So in this example, you can see that they've already shown us that this is equivalent to 1 whole, that this represents 1 whole, and then let me see what we have divided this up into. So for my denominator, that's going to show the total number of units, 1, 2, 3, 4. So now I know that these are each fourths, and this would be 1/4, 2/4, 3/4, and 4/4. And of course we start with 0/4. So let's go ahead and do that. So I have 0/4, I have 1/4, I have 2/4, I have 3/4, and I have 4/4. And remember, 4 over 4 is equal to 1. So now what we want to do is we want to go ahead and circle the one that corresponds, or that is also names the shaded part of the tape diagram. Well, the shaded part ends right here, so 1/4 names that shaded part. So I'm going to go ahead and circle that. So that is a pretty easy problem to do, and I have full faith in all of you that you will be able to do example 1B and 1C on your own after that. So I'm going to go ahead and go to the next problem in our problem set, and that's going to be problem number 2. Now for problem 2, it says write the number sentences using multiplication to show. So here we're not actually going to be drawing tape diagrams, we're going to be jumping right into the multiplication sentence.